Multi-engine piston. This is based on the Seneca 3. It's a low-wing monoplane with retractable undercarriage powered by twin reciprocating supercharged engines, driven by counter-rotating constant speed propellers. The aeroplane details include masses for a maximum takeoff mass of 4,750 pounds, a maximum zero fuel mass of 4,470 pounds, and a maximum landing mass of 4,513 pounds. The maximum fuel load is 123 USG. The fuel density is 6 pounds per US gallon. Figure 3.1 is for the climb. Going on the left hand side with an outside air temperature, horizontally across for the cruise and the departure airfield to hit 3 lines, one for fuel, one for time and one for distance. Drop down to get 2 sets of values if your departure wasn't from sea level, and subtracting one from the other you can work out fuel to climb, time to climb and distance to climb. Figure 3.2 is range. Starting on the left hand side with the cruise altitude, travel horizontally right to the respective power settings to drop down to read the range with a 45-minute reserve or the range with no reserve. Figure 3.3. This is a power setting table. Various powers of 75, 65, 55 and 45% with respective fuel flows in gallons per hour, ranging from 29 down to 16 gallons per hour, which also includes RPM settings. The manifold pressures may be gleaned from the main part of the table for various altitudes and are in inches of mercury. Figure 3.4 is a graph simply to calculate true airspeed. Starting with an outside air temperature and cruising level, pressure, altitude, go horizontally across to whichever power setting you're using and then drop down to read the true airspeed. Figure 3.5 is a graph for endurance. Come across from the left with cruising altitude to calculate the endurance with a 45-minute reserve or the endurance with no reserve by just dropping down. 3.6 is the descent graph. Going on the left hand side with the outside air temperatures from the cruise altitude down to the altitude of the destination. Go horizontally right to the fuel, time and distance lines and drop down to get sets of numbers. Subtract the smaller ones from the larger ones to get the fuel to descend, the time to descend and the distance to descend.